Got it. So just to go back to this even-odd thing, if f of negative x is equal to negative f of x, that was an odd function. This is what you have in your notes somewhere back in chapter 2. Okay? If f of negative x equals f of x, that's an even function. So those are definitions that you at one point did learn this year. So if sine of negative x is equal to negative sine of x, what kind of function would you call that one? That's an odd function. Cosine of negative x is equal just to cosine of x. It's an even function. And tangent negative x is equal to negative tangent of x. That's an odd function. So, just for sake of time, there are a couple, maybe one identity that I assign in your homework that's going to make use of these even and odd identities. We need to move on. I guess that wasn't even an example, was it? Those were just more identities. Now let's do example 4.
I have no example 4 though.
Put an arrow underneath it.
Yeah, that's right.
Don't you use the... Okay, I guess that makes sense.
So, verify the identity. Cosine of x over 1 minus sine of x is equal to the secant of x plus tangent of x. There are certain types.
I feel like it makes sense already.
Well, there's certain types of identities where you do something a little bit different that we haven't done yet. Look back up in your notes at the guidelines. I gave you 2. Choose a side, use only that side, use known identities to change that side to look like the other side. You're going to use those 2 guidelines 90% of the time. Okay? For something like this, you have to do something a little bit different. Or it helps if you do something a little bit different. Okay? Let's focus on the left side here. So we're going to have cosine of x over 1 minus sine of x. Rather than using identities, we're going to do this. What's that called?
Yeah.
It starts with a C. I think I heard somebody say it. This is the conjugate. Right? This is the conjugate. 1 minus sine of x.
That's something that you just start to recognize. If we had 1 minus sine of x on a denominator, we could multiply the top and bottom by the conjugate.
Why is that? What happens when you multiply? Let's take a look at what happens when you multiply the top and bottom by the conjugate. So the problem here is, you guys, 1 minus sine of x, that's very, very close to an identity, but it's not one of our identities. What's missing? What's the problem here with 1 minus sine of x? It needs a square, right? What if this were 1 minus sine squared? What would that equal? What's 1 minus sine squared? 1 minus sine squared is cosine squared. So if this were 1 minus sine squared, we could change this into cosine squared. So that's the point. If we multiply 1 minus sine by 1 plus sine and FOIL that all out in the denominator, 1 times 1 is 1. What's it going to be if we multiply this whole thing up? 1 times 1 is 1. That's all we have so far. Where did the other 2 go? We're going to have a plus sine of x. We're going to have a minus sine of x. And we're going to have a minus sine squared of x. So you're right, those middle cancel each other out. In the top, distribute the cosine. And you have the cosine of x plus cosine of x sine of x. So in the denominator, we have 1 minus sine squared of x over cosine x plus cosine of x sine of x. So what we did here, well, I guess we have used that identity now, but well, we haven't used any identities. All we did is multiply the top and bottom by the conjugate to put the denominator into a form that we could use an identity. 1 minus sine squared, that's cosine. That's cosine. So this, we have cosine x plus cosine x sine of x all over cosine squared of x. We have to keep in mind the direction we're supposed to head. It's supposed to equal secant and tangent. How are we going to change cosines and sines into secants and tangents? Yeah, choose between our identities. Are we going to use Pythagorean identities or ratio identities? Keep in mind what it is we want to do, though. We want to change sines and cosines into secants and tangents. So probably some ratio identities here. Okay, put some thought into it. We'll wait. Trust me, if you just kind of sit back and then when somebody else doesn't answer, you write it down, you will never get good at these. And this test is going to be very hard for you. You've got to practice looking at this and coming up with the next step on your own. If you think you have a next step, hold it back for a second. Let people think. I know from experience, okay? You can't just sit back and let other people do the work for you with this kind of stuff. This is not just mindless arithmetic where you add, subtract things to both sides to get an answer. This requires creativity. This requires a lot of thought. So this needs to be your undivided attention right now. Not your cell phones, not your iPods. Okay.
Since there's a addition sign on the top, doesn't it mean all of those are connected? So can you sweep?
The ones on the top are connected, yeah.
Yeah, so can you do a ratio? Ratio identity within
What do you mean? Keep going.
Well, like how you can't cancel out things when there's an addition sign on the top, like if you have x plus y and you have x on the bottom.
So you're saying like you can't just cancel this cosine with one of those?
Yeah.
That's true.
Okay.
Keep going. Just this one with that one? Is that what you're saying?
Yes, you can't do all of the cosine of x.
Oh, could you separate that into cosine of x over cosine squared of x plus and then different? So like switch them into two different fractions.
Did you guys hear that? That's something that you use very often. Everybody look up at the screen. If you have one single term in the denominator, this is something you have to start recognizing because it helps a ton. If you have one single term in the denominator, but multiple terms in the numerator, you can separate that into multiple fractions. Did you guys all hear and understand that? Right now we have one single fraction, right? But because the denominator is a single term, you can separate this into cosine of x over cosine squared of x plus cosine of x sine of x over cosine squared of x. Because if you were to combine these two back into one fraction, wouldn't you end up with this anyway? Why separate? Now, let me explain why separating was such a good idea. Take a look at the direction we need to head. This is two separate terms, right? So we probably ought to have two separate terms here, and then simplify. Go ahead.
The second one, you can cancel the cosine, and on the side over the other cosine.
We're basically there, you guys. This cosine cancels with one of these cosines, so this equals 1 over the cosine of x. And then this cosine here cancels with one of those cosines, so that's sine over cosine. 1 over cosine is the secant, and sine over cosine is the tangent. Secant of x plus tangent of x. So let's keep going with this. The thing about these identities is you can't just do 3 or 4 and think you've got it. There are so many variations. There's different tricks. There's different ways to do it. I've assigned quite a few from this section. It's going to be on the website. You need to make sure that you guys really, truly do the homework. Now, I want to talk to you guys for a second about your homework. Let's do example 5. Still a little bit more of an easier one. Cosecant of x minus sine of x equals cosine of x cotangent of x. This one's nice because one side really isn't more complicated than the other. If you choose the left side, you'll get somewhere. If you choose the right side, you may get somewhere. Doesn't really matter. We've been choosing only the left side. How about we choose the right side for once? That right side's getting neglected. Let's see if we can choose this right side and make our way to the left side. So cosine of x, cotangent of x. Somehow that's got to separate into two separate terms, separated by a minus sign. One's cosecant, one's sine. This is one of those where you are going to use known identities. You don't really need to create your own clever steps. Use known identities. And you have to focus. I know it's Friday before spring break. You guys are old enough and mature enough to be expected to focus on a day like this. So you're changing cotangent, right? Okay. So this is cosine of x multiplied. You're using that ratio identity. Cosine of x over sine of x. That is absolutely correct, that cotangent is equal to cosine over sine. Now you guys do need to be aware, sometimes you get a couple steps into an identity and you just have to abandon that and start over. That happens. You have to be willing just to try stuff. Even if you don't think it's going to go anywhere, try it. Okay? You never know if you're going to get anywhere if you don't even start something. So where can we go with this? Yeah. Cosine times cosine is cosine squared, so this changes into cosine squared of x over sine of x. We're getting close. We're getting closer. Exactly. Let me point out something to you guys. We have one term pretty much that needs to somehow be separated into two terms. So you might be thinking, well, how can I separate this into two terms? Cosine squared can be separated into two terms using the Pythagorean identity. Cosine squared equals what? There's actually a couple different versions of the Pythagorean identities. Let's take a look. Where did you go? Where'd you go? The original Pythagorean identity, sine squared plus cosine squared equals 1. If you just subtracted one of the terms on the other side, you would get these variations. Cosine squared then equals 1 minus sine squared. So 1 minus sine squared of x over sine of x. And this is...
And you can cancel one of the not from the
Well, say that again.
you can cancel one of the signs for one of the
We have to separate first. Because this is 1 minus sine squared, you can't mess with the sine squared. It's connected to that term. This is the same trick we did last time, right? If we have one, and you guys, if you can start to recognize this, it makes your identities a lot easier. If you have one term on the denominator and multiple terms in the numerator, you can separate it out into separate terms, separate fractions, rather.
So we get 1 over sine of x minus,
which is the cosecant of x.
exactly, sine squared of x over sine of x. 1 over the sine. What is 1 over sine? Hey, Cam. Cam's got it. Yeah. I love these trig identities.
Thanks.
We're just about there. Sine squared over sine. That's just sine of x, right? The sine cancels with the sine. Is that what we wanted? I forgot where we even wanted to go. Yep, cosine or cosecant minus sine. There we go.
Could you manipulate both sides to both equal, like, if you can work both
Okay,
sides?
you need to be
like, on the
careful.
middle?
We need to be careful on how we describe that. Did everybody hear the question? I said last time that you can't do the same operation to both sides.
Yeah.
And that's correct. You can't do the same operation, but in certain cases you can manipulate both sides.
In certain cases or in all cases?
In certain cases, I don't know if we'll get into that today, but you can manipulate both sides using identities so that they equal the same thing. So they meet up in the middle. Sometimes it's okay to do it. Let's get a little bit more complicated. Example 6.
Why don't we go back to example 1?
Back to example 1.
The example example.
Oh.
That we never did.
Oh, from that, I see what you're saying. We'll get there.
Okay.
What example were you on?
6.
6. Holy crap. Okay, we need to get started actually on 7.2. Let's do one more and then we'll get started on 7.2. Here's example 6.
We don't have to start at 7.
We do have to start at 7.2.
Sorry.
Okay. Okay, sine of x over sine of x plus cosine of x equals tangent of x over 1 plus tangent of x. Want to start with the left side?
We have the left side right now.
We can only separate if it's a single term in the denominator. Yeah, not in the numerator. They both look about the same. If we want to start with the left, that's fine. We'll start with the left. Sine of x over sine of x plus cosine of x. It is, isn't it? Dang it.
Should we do something about that? I think we should.
Yeah, there's probably a lot of things we could start with, and I don't.
I have a question.
That's the
If
thing.
you can jump the lines which you said, and do like the negatives and then.
If there's negative exponents, we could jump line switch signs. You had a question, Kim?
Could you, I've already forgot what terms called, like, times top and bottom by like minus, and like, so it's just x minus cosine.
Let's try it. So, sine of x minus cosine of x, and then over here we're going to have sine of x minus cosine of x. So we're multiplying the top and bottom. Now again, like I said, we may get a few steps into this and realize, okay, we better back up. Let's see what happens here. In the numerator, we get sine squared of x minus sine of x cosine of x. Ooh, this is going to get tricky here in the denominator. It doesn't get complicated?
Well, then it's sine squared of x minus the cosine of x.
Okay, that's right. Whenever you multiply something by its conjugate, you get the difference of the squares of the two terms. So it's going to be sine squared of x minus cosine squared
Now you can separate
of x.
Okay.
Still can't. It has to be a single term in the denominator. Single term. Now, don't. A lot of students make a mistake. Sine squared of x minus cosine. That looks.
Not a Pythagorean identity.
It's not. It looks similar, but what's the problem here? It's minus. It's supposed to be plus, so we can't use that identity, or at least that Pythagorean identity.
But the sine squared of x equals 1 minus the cosine squared of x.
True. We can't cancel those out because they're part of these terms right here. If it's separated by plus or minus signs, that's part of a term, and you can't cancel out parts of terms, only a whole term.
Change sine squared of x to 1 times cosine.
Which sine squared?
Both.
The bottom one, both of them?
No.
Both of them? So sine squared is 1 minus cosine squared of x minus sine of x cosine of x. And in the bottom we're going to have 1 minus cosine squared of x minus cosine squared of x. We can combine which cosines? So that's 1 minus 2 cosine squared of x.
I feel like we're making this more complicated.
Not really anything we can combine in the numerator. Let's go back up and take a look at where we're supposed to head with this. It's supposed to be tangent over 1 plus tangent.
Well, we should get secant. If we get secant, then we'll do somehow the Pythagorean identity.
Let me point something out to you here. We've got a bunch of things being squared and everything else, but if you take a look at the result we're supposed to have, nothing really is squared. I don't know. Something to think of.
I'm going to restart.
Yeah.
Sorry, can you change something on the bottom? So like, if you go back to the first equation we have on the left, this is just a question now. Can you take like the sine of x and turn it into cosecant x, and then it would be 1 over cosecant x sine x plus cosecant.
Here,
No, back to the like initial equation.
let's go back to the original and perhaps try a different route.
We're starting with the other side because the tangent of x is the sine is equal to the sine of x over the cosine of x.
Okay. You're starting with the right side?
Yeah.
But can you do that with like an addition, like two separate terms on the bottom? Can you change the top sine of x into cosecant x so that it would be 1 on the top. Cosecant.
You can change this to 1 over cosecant. Is that what you're talking about?
Yeah.
This can be 1 over cosecant.
So then what would that change the equation to?
Let me.
The fraction just have to stay on top.
Here's something we could. Well. Is that what your suggestion was?
Well, yeah. Well, I'm not saying that's what we should do, but I'm just wondering if you did that, would it just stay like that, or could you put the cosecant on the bottom somehow?
We could manipulate this a little bit. Dividing a fraction divided by this is the same as multiplying by the reciprocal of that. Does that make sense?
Yeah.
So you could, that could be a route you could go.
Okay.
Let me change it back to sine. Maybe we chose the incorrect side. Maybe the left side wasn't the way to go. Maybe we should have chosen the right side. What are you giving them hints we haven't got to yet?
Maybe.
Well, we're ahead of you.
We haven't done double or half yet.
We're on
I think.
example B. Oh, you're looking at
Okay. So should we try the tangent x over 1 plus tangent?
I don't know. One thing you guys need to consider. I don't know if I mentioned this last time. Many of you up until this point have had a very easy time in mathematics. Okay, it does. Okay. So you can't think, well, everything's always been easy for me, so this needs to be easy. No, it doesn't need to be easy. It might be hard. And on the flip side, for some of you that have struggled with the arithmetic and the algorithms, this might come a little bit easier because it's a little more creative thinking, and so it's different.
That's what I was looking for. I didn't find it.
Oh, you got them? So you guys over there started with the right side, didn't you, Addie?
Yeah.
Have you gotten anywhere on the right side?
But I gave her an idea.
No.
It's a guy that's in jail drinking out of something.
What?
Haven't heard that one.
A common cupid.
Oh. We tried that.
On the tangent side?
Not on the tangent side. We tried it on the sine cosine side. We've gotten real messy. We tried the top and bottom by the conjugate of sine plus cosine.
Well, that's an identity. You just don't know that it. I haven't learned the double ones yet. No. That's a big negative. These are my favorite things. When you get too good at them, they're like little math puzzles.
It is fun.
And your little math nerd inside starts to giggle. I enjoy it.
We all have a math nerd inside us. Are we abandoning the left side completely?
Yes.
Alright.
Abandon ship.
Abandon ship. We were on a sinking ship. So we have tangent of x over 1 plus tangent of x. Should we try the conjugate here? So that's going to be 1 minus tangent of x, or 1 minus tangent of x. You had a question?
We don't have to conjugate this tangent of x plus 1 with secant.
You're really close, but if it was 1 plus tangent squared, we'd have to have an exponent there. But that's kind of what we're working towards here. By doing the conjugate, we're going to introduce an exponent. So then you might be right. Let's take a look.
What did you say?
Well, what happens when you multiply a term with its conjugate?
1 minus tangent squared x.
Yeah, it's going to be 1 minus tangent squared of x. And then in the numerator, you're going to have, what are we going to have? Tangent, tangent of x, if you distribute there. And then if you distribute here, you get minus tangent squared of x. Well, hey! Now take a close look, though. 1 minus tangent squared. You have to be absolutely sure that that's one of the identities. It's close. Dang it!
Like negative tangent squared x.
But you do
plus
both.
1.
Why don't you just subtract it from there and then subtract it from there? And then it's 1 minus. Never mind.
Yeah.
Oh, wait. Just subtract
tangent squared equals. Tangent would be secant squared minus 1.
Right. Yeah. That's what I'm getting at.
So this is where we are. Yeah.
Can we just make like the whole identity negative, and then we could have a negative secant and 1.
Wait, the original identity?
Yeah.
So that would, if we made this whole side negative, it would have to be negative tangent squared of x minus 1.
Yeah.
That's a good thought. If we made this and that negative, we could say that, but we don't have negative tangent squared. We have tangent squared minus 1. But that's a great thought.
I have a couple questions.
Couple questions over here.
So instead of multiplying by the conjugate, did you change tangent of x to the sine of x over the cosine of x? So instead of doing that.
I don't know if conjugates is getting us anywhere, you guys.
Yeah.
We have to try something new.
Yeah, so let's start with like changing tangent of x to the sine of x.
Let's change all the tangents. Let's change both of them. Is that what you're suggesting, or just one of them?
No, that's what we did before, and then Robert let us astray.
So wait, you did which one tangent? Which tangent did you change? Oh, you changed both of them? So the top became sine over cosine, and the bottom became 1 plus sine over cosine.
Then let's do the conjugate.
This one's a pretty challenging one.
Doesn't the base go up and the other one come down?
Let's do something here, you guys. I'm not really liking that we have two separate terms on the denominator.
Yeah.
Why haven't we combined these yet into one dang term? 1 plus sine of x over cosine of x. Let's just add them together.
Sounds good. Let's do it.
It's the same thing as sine over x, or sine x, cosine x.
What if we change 1 into cosine of x over cosine of x? Isn't that an identity?
Oh,
1 is equal to anything, right?
when you combine.
Can't we combine this now?
Yeah, well, then it's just
In the denominator, we're going to have cosine of x plus sine of x over cosine of x. Over here, we have sine of x over cosine of x. I don't know. Are we getting anywhere with this?
You multiply by the reciprocal.
Let's try a reciprocal thing here. So, well, the reciprocal of which one?
Bottom.
We take the reciprocal of the bottom one, so now we have sine of x over cosine of x. Multiply. Okay, be careful. What are we multiplying by? Okay. You gotta be careful here. When we're changing division to multiplication, we do. So it's the cosine of x over cosine of x plus
Oh my gosh.
sine of x.
I think I just
Oh my god.
We're close, you guys. We're knocking on the door. Cam, go ahead. Okay, which cosines? Did you guys hear that? The one on the top? Well, which one on the bottom? This one here? So now we have the sine of x over cosine of x plus sine of x. Now, you guys, let me explain what happened here. And that's why these just take a lot of practice. Sometimes, yeah, conjugates are great. Was it great here? No. What were some of the other hints I talked to you about? If you have one term in the denominator, then it's separated out into multiple fractions, right? Here's another trick that sometimes works. If you have separate terms in the denominator, what did we do with them? We combined them. Okay? And then we divided by fractions. So that's one of the beasts of these identities is there's just different ways. Yeah. Yeah.
Still doing more.
Are we done?
Yeah, I forgot what we were trying to get.
Sorry,
Oh my god, now we
I forgot to circle it. There we go. We started with this, we ended up with that.
What teachers ever do for us?
Let's
Teachers just make them mad.
make you mad.
Sorry, did I say that loud?
Oh, here we go. This will be the culminating one. Example 7. Okay, be patient and long-suffering. One minus cosine of x over sine of x plus sine of x over 1 minus cosine of x equals 2 cosecant of x.
I feel like the left side is more complicated.
We have to come to an agreement, though.
Pattern. Are we going to use least common multiple?
Explain.
Like, we can combine those two terms because they're inverses of each other. We just have to make the denominators equal each other. And we'll end up getting, I think we'll only end up getting 2. I don't
So
know.
you're focusing on the left side?
Yeah, I'm focusing on the left side.
Oh, so what you multiply, you want to
Yeah,
have
you
the same
did.
denominator.
Multiplying the first one by 1 over, or by
1 minus cosine x and multiply the second by sine.
Okay, hold on a second. We need to get common denominators to combine these. Is this what you guys are trying to do?
Yeah.
Combine those. So this side needs a sine of x over sine of x. This side needs a 1 minus cosine over 1 minus cosine. Now you gotta make sure you're paying attention. Are these conjugates? No, they're not. 1 minus cosine times 1 minus cosine. You gotta be careful on this multiplication. It's not 1 minus cosine squared. What is the multiplication?
It's going to be 1 minus 2 cosine x plus cosine x.
There you go. There you go. Over our common denominator, 1 minus cosine of x, sine of x, plus sine squared of x over our common denominator, 1 minus cosine of x, sine of x. Now let's combine those into one glorious fraction. 1 minus cosine of x. I'm doing the denominator here. And 1 minus 2 cosine of x plus cosine squared x plus sine squared x.
Should we separate those into 3 separate fractions?
We could.
Well, we have to look at the Pythagorean theorem because cosine squared x plus sine.
Sometimes students have a tendency to think too big.
That's 1.
Okay, but think small here. Cosine squared plus sine squared.
That's 1.
That's 1. That's the Pythagorean identity. Cosine squared plus sine squared.
Oh,
So let's change that into 1.
that makes sense.
This, you guys see what I'm talking about? This right here? That's equal to 1. It's the Pythagorean identity. So this is 1 minus 2 cosine squared plus 1 equals 1 minus cosine of x times the sine of x.
You may just combine the bottom and the quick.
Let's not do that.
Combine the bottom.
So,
Well, wait a minute. Do these ones really cross out?
oh wait, no, there's
No, they act.
They become 2. Yeah, so this equals 2 minus 2 cosine of x over 1 minus cosine of x sine of x. We've lost sight, I think, of where we're supposed to be going. We're supposed to end up with 2 cosecant of x.
But we have 2's.
We have a couple of 2's.
you try to get the bottom.
Yeah.
There's something really easy that we're overlooking. It's right there.
The sine
I think cosine of x over the sine. Which you
Wait, say that again?
tangent.
Okay, okay.
Oh, wait, one.
You're talking about like the number 1 right here. If we put a 1 right there, is that what you're talking about?
If we don't go to the next one, then one of the sine of x is equal to the cosine of x, so we can split that off, right?
Yeah. We are going to have to do that here in a second. You're right. The 1 over the sine is
So
the
why
cosecant.
are we adding the ones together? Because if we don't add them together, then we can keep the 1 over the sine of x, which is equal to the cosecant of x.
But this plus 1 is connected to this whole entire term. We can't separate the 1. Does that make sense? We are going to have to do that eventually, but let's save that to the last step.
Because 1 plus cotangent squared equals.
Right at the bottom, the sine of x minus
Because
the
I'm trying to get cosecant.
We could distribute the sign, you guys, but I'm not going to because I want the denominators separated.
Yeah, then you separate it into no.
We could. Yeah, we could.
Technically, in the denominator, we do have one term.
What if you multiply out the bottom?
I'm going to say no. We could. You're absolutely right. We could, but I'm going to say no to that. Look in the. We're focused at the bottom, guys. Look at the top.
I see it. I see it.
Look at the numerator. Do we have a common term?
2.
What happens if we factor out the common term?
1 plus cosine x.
Do you see what I'm saying?
I was thinking about that, but I was like,
Let's explain that again. What if you factor out this 2? You would have 1 minus cosine of x. Where else do you have 1 minus cosine? On the bottom. Okay.
I was looking at that, I was like, too bad it's not divided by 2, because they would cross out the bottom.
The reason I was focused in on that is we have just a very simple term, 2 cosecant of x. Well, yeah, if you factor out the 2, you have 1 minus cosine of x. And then on the bottom, you have another 1 minus cosine of x. Sine of x. Those are gone. So you have 2 over the sine of x, which is nothing more than 2. Whoop. Cosecant of x.
Whoa. We should have a group test for everybody.
Guys, this is going to have to take a lot of your focus. Okay? These identities at the beginning are very challenging. The good news is they do get easier. They really do. Okay? Because you start to recognize patterns. That factoring out, yeah, I didn't expect you to see that at the beginning, but once you do a couple of these, you recognize that, and you get so much faster at it. Okay? Or separating multiple fractions into single fractions or vice versa. You guys will get really good at that, trust me. But you have to practice. Okay? And you have to be patient with yourself. Okay? Especially if you're the type that thinks everything ought to come easy to you. You have to understand this might not, and you got to be okay with that. You have to be okay with a little bit of uncertainty at the beginning of a problem. I know it's hard, but we aren't going to have time for 7.2. Let's just practice one more. I'm going to write it down. I want you guys just to go with it. Okay? I'm not going to give any help, no hints. I want you guys just to go.
It's a race. It's a race.
Just roll with it.
Roll with it.
1 plus tangent of x over 1 minus tangent of x equals cosine of x plus sine of x over cosine of x minus sine of x.
Okay.